distracted by one thing. Wait, let me just. Okay, Ken. Let's start with this, yeah. Okay, but why? Plane mirror. Yeah, virtual and upright lah. Virtual and upright. But why would? But okay, here's the thing. It's virtual, upright, and laterally inverted. So yeah, I mean, you don't just like get the mark. You must understand the concept also. So it changed it to D. It changed it to D. Virtual upright, laterally inverted. Can you get you guys to write this down? It's laterally inverted. Means what? So it's not inverted, it's upright, but then it's laterally inverted. What does it mean? Left and right. Yeah. Yes, that's right. Right become left, left become right. Okay. Then question 2. Change in direction to the light ray. Oh, no. Yeah, it's tough. This one is tough because the light ray is originally like this. Okay. Then they're asking for this angle of deviation. Yeah. Okay. Yeah. Like, okay. This is not TIR, dude. Yeah. Okay, so that one, you understand that. This one here, what?
But the answer for this one, right, is because everything else is wrong.
Yeah, so.
But they said this one is also quite wrong and correct at the same time. The UP. I don't know. It's not very hard. So that they say it's hard.
Yeah, let me think first. Let me think first. Okay, firstly, this question is not fair because this is a 2 non-air mediums, which is only for IP, not for express. Okay, so the plastic cylinder also has its own refractive index and it has to be more than 1.4. So maybe let's say it's 1.6, for example. Okay, but without knowing what's the actual amount of what's the actual amount of like what's the I mean the equation to be used is Snell's law, the full Snell's law, but you really don't have to care about this because it's not within your syllabus, right? This is for the actual O levels only. So light ray will refract into liquid if angle of incidence is decreased, right? Let's say I decrease it to 69.9. It's not fair, right? So you don't actually know what is the critical angle, correct? Yeah, you don't exactly know, right? Because furthermore, you don't even know how to calculate critical angle between 2 non-air mediums, right? This medium there is 1.4, the other one is 1.6. Yeah, there's no way for you to. Yeah, so in a way, this question is a little bit fair and unfair at the same time. It's not really tough because if you can identify that A, C, and D are definitely right, then B is the only answer that you can choose. Like which one? Why is D right? Speed of light. Because it has a higher refractive index. Let's say you have a refractive index of 2.5 and a refractive of 1.4. Which one is the higher refractive index? 2.5, right? But what does the 2.5 represent? It represents the ratio of speed of light in vacuum to the medium. So vacuum is 2.5 times the medium speed. Then if the refractive index 1.4, then it's 1.4 times the slower the speed in the medium. Because N equals to C over V in the medium. Speed of light in vacuum. Yeah. So what you're saying is that the speed of light in vacuum is 2.5 times the speed of light in the medium. Right? Or you can say the medium speed is 2.5, like speed of light divided by 2.5. right? Yeah, divided by 2.5. So it's slower lah inside the medium, right? So if you divide by 2.5 versus you divide by 1.4, the one divided by 2.5 will be much slower. So speed of light in diamond is very slow. Because diamond has a very high refractive index. That's why you have a lot of total internal reflection inside a diamond. Don't mix up diamond and prism, huh? Yeah. No, it's not. It's not. Okay. Oh, critical angle is just B. Because if this outside is air, and this one here, if this, and you know that this 90 degrees, then this one B is your critical angle. Yeah. This one is not even like this. Hey, this one is 2 seconds. Hey, like this is a 2-second question. 2 seconds. You look at this critical angle B. Come on. Huh? No lah. They're asking what's the critical angle lah. Okay. Oh gosh. Wait. I just want to see what's the question. So the important thing is this. How do you know the answer for this? Because you went to memorize, right? If your focal length is 10, your object distance should be less than 10. So you memorized it, right? Great. That's the whole point for lenses. Right? A lot of students don't memorize. That's why. Oh, what's going on here? So what's up with the man? What the heck is he wearing? Huh? What? Sorry. Oh, you drew dotted lines. But you realize, right? Do you realize that this 3 marks here? No, it's the first thing I did for reflection, right? Like, what do you do first? You find the image first. You find the image first. Then you draw a straight line from the image. This is what Sam did. But then he forgot to draw a straight line, a solid line here. Huh? Okay. So some teachers are lenient with that. But you see, you technically speaking, right, I would have marked you down for that one. Huh? It's not about the angle. He go and put an arrow there. You're telling me the light shooting behind the mirror. Huh? He got a tick for that. But the problem is that I would put a cross. That's wrong. Dude, that's wrong. Yeah. And you should draw a dotted line behind the mirror. Yeah, because dotted lines have no arrows. Yeah. Yeah, you almost lost another mark. No, you almost lost another mark. You didn't draw the arrow here. You almost lost another mark. You didn't draw the arrow here. Yeah. Okay? So light ray from the feet is reflecting into the eye. Do not use a protractor. You don't need to use a protractor at all. But they ask you to label the angle of incidence, right? Okay, can. It doesn't matter. It doesn't matter. The construction is the important one. If you construct it properly, you will get it correct. So which means that, right? You may have lost another mark. How many marks do you have there? 5. Yeah, like 5, then he got 3, right? Okay? You have to measure this distance and this distance. It must be the same distance. It looks like it's not the same distance to me. You need to measure this distance and this distance. Right from the start of my reflection, I said you locate, you must be, don't guesstimate. If they ask you to draw to scale, you have to draw it properly. Okay, next one, come. I went through the semicircles, right? Okay, and it's the angle of incidence in optically denser medium, for which the angle of refraction in an optically less dense medium is 90 degrees. Don't need, and its angle is 90 degrees. It's 90 degrees. Okay. Is that not good enough? You need to compare the optically denser and optically less dense. But you didn't specify 90 degrees is in the optically less dense medium. Basically, I'll tell you this. Your words are not clear. Your phrasing is not clear. So they don't give you the mark. That's it. End of story. Right? So you understand what is at stake here, no? You go to exam, O levels this year, right? It's going to be like that. Your marks are at stake based on how precise you give your answers. You understand what I'm saying? Do you realize that there's actually no official answer key for O-level TYS? Right? Yeah, it's basically they take samples from everyone, right? Then they judge all their answers. They say that if your answers look like this, deserve 1 mark. If your answer looks like that, if they take yours as a sample, they say no marks given for that. Oh, okay. Oh, ouch. Yeah, yeah. So do you know that the TYS answer is written by the publisher themselves? Huh? Yeah lah. So then he goes around and then he says that he's the author of the TYS answer key, right? Then and I mean it's like the problem. No, but the problem is you go and look at answer key year after year, right? It's getting more and more bloated. The answer he keeps on adding stuff to it. So a 1 mark question can be written like 8 lines like that. Correct. He wants to ensure it's absolutely correct, right? But then that's not the point. The point is, then what students gonna write 8 lines for that for 1 mark? No, right? Okay. I don't know. Actually, well, does it bend away from the normal? Yeah, you made it bend away from the normal, right? Then you didn't arrow, lor. Yeah, yeah. So you know what? Okay, do you know what's the worst thing or not? No, yeah, you damn heng. He let you go, right? Okay, you know what's the worst thing? The worst thing is like you all understand, right? But you all lose the marks. The problem is, do you realize that that's been happening since your PSLE? You all understand the concept, but you all keep losing marks. You all never get the grade that you want because you need to be ultra super meticulous. Don't just do the test paper just to get it over and done with, you know. You have to tell yourself, I need to be ultra super meticulous in giving the answer. So when you do this, right, don't just say, okay, I got this in the bag, let's move on. No, double check, triple check. Did I draw the arrows? Okay, be very, very ultra super meticulous, right? I'll tell you this, okay? Being ultra super meticulous is not just for your O levels. It's for you to do in your life's work also next time. You go out to work next time, right? Ultra super meticulous. Whatever you do also. Oh, you had a unit degree. Oh my gosh. Yeah lah. So I'll tell you that the more or less the new rulings is either you put 2 or 3 SF, it doesn't matter. Yeah. Okay, what's this? Then your arrows, You see your arrows cost you marks,
In my head, right? I was just remembering that it bends towards the thing, but then I forgot that it's not the one.
Oh my gosh, the one that passes through the center will continue passing through the center all the way. And then you go and draw your image upright. Brother, where are the light rays coming from? Wait. I draw for you a person here. The person here, okay? That's his head. That's the top of his head. The light rays pass through the lens, right? It should form the top of his head. So he will be inverted inside the image. Like that. Like that. He'll look like that. You get it? Okay, again. You all easily can get full marks on this whole paper. Come on, man. Hey, why you say the image is virtual? A fella image is made from real light rays, right? This is a real image. There's only one virtual image for, the magnifying glass. This is a real image. But not only just that, I want you to remember this. This image is real because the real light rays, are forming the image for you. So this is a real image made from real light rays. What?
Image form is real. From the diagram, image conversions below principle, and you did right, and can be captured on screen. So you did right the key point. I thought rays converge at the forming converge. Yeah, you did forming. That's what he said.
I want you to write this. Okay, the proper one. Okay, I think not just rays. Real light rays converge at the opposite side of the lens, forming the real image. Like this is to remind you, real light rays form real images. I know this is the answer key, but I'm trying to say I want you to write this. This one I want you to improve on your answers. even if it's the answer key. I know lah. You converge below the principal axis doesn't make it real. The reason why it's real is not because it's converging under the principal axis. Do you see a screen? Did they say that it was captured on the screen? Right. They are not, brother, they are not asking you how should he view, or rather, they're not asking you what's the difference between real and virtual images. If they're asking you that, then you can say real images can be captured on the screen. But they are not telling you, yeah. Like, the logic is there, the correlation, causation, and correlation. Okay, anyway. So next one. State 2, okay, this one's correct, Diminished, diminished and inverted. Okay, you can tell me inverted, but then yet your image up there is upright, brother. That's not inverted, right? Your arrowhead is still pointing up. Upside down, the fella upside down. Okay. This one is what? This. Oh, okay. No, this one. He changed something, is it? Okay, so you all got this,
If you ask me in the diagram, I think I thought like the large value will have to be 0.2 by 3 because it's 0.2 by 3, then you will reach pretty well first.
Huh?
I should do it up.
Yeah, you should draw. Oh, the next page, is it? Oh, you didn't scan, you didn't scan the page. Yeah, you didn't scan the page. Okay, wait, Hey. Okay, you go back and check, So, but anyway, the whole idea is, Which one? This one, Come here. Give me a diagram. No. Give me the diagram there. You didn't take picture. I wanted to use. So in my Telegram answer to you was that if you zoom in, right, you can see that the edges here are getting less and less slanted. So if it's less and less slanted, right, because you were asking me how is it happening, right? So I was telling you that the ones near the edges, right, the edges are very slanted. Okay, they are very slanted. So the bending is more. But then towards the center, the slant edges are getting less and less angled, right? They're becoming more vertical. So the bending of the light rays is less. Okay? So therefore, right, all the light rays that are parallel coming into this lens, they will all converge at a point because the ones on the outside bend more, the ones on the nearer the center bends less. So they all converge at this point behind the lens here. That was what I was trying to describe to you inside the Telegram message. Yeah.
I don't know how I get
2 more marks, 22. What? Okay, so higher refractive index is used, right? State and explain the changes of the light rays after passing through the lens. So high refractive index means they bend more. They will converge earlier, correct? I don't know what you write. Light rays will bend more.
And hence they converge earlier. That's why I asked him, he said he didn't write light rays. This would converge earlier. But you said the band went to normal, so key point.
Light rays will bend more as refractive index is increased. Light rays gain more. No, dude. You didn't have to talk about the gain more speed. I think you lost the mark because of that part. Yeah, correct. No, you see, right? The lens, the light rays didn't gain more speed, no? After passing through the lens, no, you say that, right? You're saying that okay, I know what you're saying. But you must understand, the light ray had a certain speed outside, right? The light ray had a certain speed outside. It goes into the glass, it slows down. But once it comes out again, it gets back the same speed that it had when it was outside. Yeah, it regains speed, right? But then again, that still doesn't add into, doesn't matter to this question. The question is asking you, like, how will it bend, right? I mean, that's it. That was the answer. It will bend more. Higher refractive index. I know what you're thinking. Higher refractive index means it slows down more, right? Okay, so if you have written like that, inside the lens, the light ray will slow down more. Upon coming out of the lens, right, the change in speed will be greater and therefore it will bend more. You understand what I'm saying? I know what you're talking about. But the way you're phrasing it makes it a bit like too complicated. Yeah, too convoluted. So unfortunately, it can't give you the mark because of that. All right. So you have to check the mark allocation, bro. I know what you're thinking. You're thinking 2 steps, 3 steps in depth. I understand that. I can sense that from you, right? The mark allocation is 2 marks. Okay. So technically speaking, right, if you have 2 points, they bend more and therefore converge earlier, or you can say the focal length is shorter. That's 2 marks worth already. You don't have to explain any further than that. I know what you're thinking of. You're saying that the change in speed is greater, right? I get that. That is if it's a 3-mark question or maybe a 4-mark question even, right? So you have to learn how to manage the points and the mark allocation, right? That's another skill on its own, no? That's another skill. You don't want to write 8 lines for 1 mark. Mm. You just said it converged earlier, what? Yeah, that's what focal length is, brother. Right? Your lens like that. Then if you converge like this versus another lens like that, and then the lead ray converge like this. This one the focal length is shorter, this one focal length is longer. Yeah. Man. Huh? Okay, that's good. All right, I'm done. All right. Good. I mean, really good attempt, to be honest. It's just that yes, the last question was giveaway, but I think without the last question, you did quite well on your own for the other questions also. So that was a good thing, other than from the careless mistakes. So remember, always be super meticulous. All right, bye guys. Bye bye.